Alright, hey guys, welcome back to the channel. So today I got another project, and this is one that I've actually been commissioned to build. I have some friends that own a children's museum, so we're going to be building a blower table, or a Bernoulli table, is what it's also called. And they asked for some help with this because they were looking to have this purchased from a supplier that builds these children's exhibits for children's museums. Problem was, these tables were pretty solidly in the 5 digits, over $10,000, $20,000, which I think is very ridiculous. And so they asked if I could build one, and I think I could. So I was kind of brainstorming this for quite a while and trying to determine what I could do. So a Bernoulli table or blower table is really just a table that's like a cabinet, and it has holes in the top. And so when you hit a button to turn the blower fan on, it's going to blow air out of the holes from the tabletop, and it's going to blow air vertically, and you can put a ball on the air and it'll kind of hold it there. Kind of the next level is adding a way to kind of directional move that air with some sort of nozzle, and then that can move it a little bit. You're not going to have it directly sideways really, but so that way the ball, you can kind of move the ball with the air. So coming up with different ideas. So I started out with a shop vac, and then I kind of moved on from there. But anyway, I'll show you kind of the different stages of my thought process, and then we'll kind of get into the build and some of the parts and complicated part of it that I'm still trying to figure out. So anyway, so let's get started. Okay, so my first kind of thought process go around for this was making a square cabinet table with 3 shop vacs in it. So this is a very small shop vac, and using it on the blower side where it's going to blow air out of this hose. And that was going to be kind of the first thought process, was that the motor that's making the airflow is going to be easily replaceable, and it can just kind of, there's nothing fancy with it. And so that's what the shop vac idea came from. And then it also had a nozzle that I could put through a hole in the tabletop, and then the kids can kind of directionally move the nozzle around. However, after talking with my friends about this concept, the kids would tear this nozzle to pieces. Mainly, the first thing I want to try to do is yank it out of the table or push it in, or it's going to get flattened over. And this plastic is just, it's flexible enough, but not for wild animals to get a hold of. So I think this idea would have worked if it wasn't for wild kids. But it also is a little noisy. So you hear that? It's kind of noisy, but it does the job in shooting the ball up. It actually, for this size ball, it's kind of too high. But see how it holds it, and you can kind of move it around. Anyway, it was able to hold it in the air a good bit. Kind of solved a lot of the problems there with moving the nozzle cheap, and but it was a little noisy, and the airflow wasn't quite there. Maybe I could probably do a little better. So kind of scrapped this idea, and I'm going to a blower motor. And so let me go get that, and I'll show you what that looks like. All right, so I found this blower motor on Amazon, I believe, and it has about a 3-inch hole here for the air output. And this is meant for like a kid's, what are they, like a bouncy house that you would have, like a personal one in your backyard, not the big giant ones you'd rent for a birthday party, but kind of a personal one. It's a little more robust feeling, and it's kind of made for blowing air, so I think it'll last longer also if it's going to be on a lot. So this one, it blows air. It's maybe not quite as loud. It's probably 10 times more air coming out of here. The only issue is I have 2 of these, and the other one, we're just going to blow the air, and it had this nozzle for it to come out of the top. With this one, it's a little bit more complicated now, and then I'm going to be using PVC to direct it through the cabinet. The other concept of that is that the client, my friends, wanted to see the tubes that it's flowing through. Even though you can't see the air moving, it's just neat to see the tubes where the air is flowing out of. So I'm going to have this blower attach some PVC to it, and then it's going to split into 2. So it'll have 2 nozzles coming out of the table from one blower. I'm gonna have two blowers, so there'll be 4 nozzles out of the top. And then from there, I have to be sure that the airflow is kind of correct. It's plenty, volume of air is plenty there, so I just want to be sure it doesn't come out of one nozzle faster than the other one or something like that. Also, didn't talk about with the shop vac is a way to turn it on and off. That's one part that was kind of more complicated to me, and I haven't really thought it all the way through yet, is I don't want it to just, I could rewire the switch and just put a switch, an on-off switch on the top, you know, that's no problem. That'd be kind of too easy, I think. But the issue is kids will come over, hit the on button, and then walk away after a while, and it will just stay running all day long, you know, and that's not good. So I wanted to get a circuit board for each of these that would have a timer, so I could set it for like run for 3 minutes or something. So they'd hit the button and it would just stay on for 3 minutes and then it automatically turn off. So first we're going to start building the cabinet, and I'll show you the dimensions of all that, and then we'll as things start coming in the mail, I'll be building the other pieces. So anyway, so this would be kind of a neat project. I thought you would be interested to see this one, so let's get started on building this cabinet. So the plan is to make it basically a 24-inch tube that's 6 foot 8 inches long, and so it's also going to be on feet, so it'll be a little bit taller, and then plus the thickness of the top, which is another half-inch piece of this sheet of plywood. So it'll be about, you know, 26, 27 inches off the ground. This just gives you an idea of where I'm at. This is one of the blower motors. I'm going to have a second one to the right here, and then this divider I think I'm going to put at 24 inches, which is about right here, and that's going to, you know, divide the blower from all the pipe. And this just gives you an idea of kind of what that divider, you know, these two chambers are going to look like. All right, I'm going to take a break from the cabinet itself and start working on this circuit board and kind of the operation of running these blowers. We'll start with, I have a power strip here that's I'll be putting inside the cabinet. Now this is going to plug in all the blowers and whatnot. And then I have a power supply, which was to a scanner, actually an old scanner, and it's 24 volts. So it's turning this AC into 24 DC, and it goes into the circuit board. And then you have this side of the relay is the actual, you know, AC power that you're going to be operating. So this will end up being the blowers themselves, but for now this is just an extension cord to this heat gun. So we'll go through the circuit board itself. So we'll kind of start on the left side. There's 4 plugs here, and I wanted to try, actually before I do that, it does run off of a micro USB. And I thought that was the plan initially because I could run it off these USB ports and then turn on the circuit board. But it does turn it on, and you can program it and whatnot, but you can't trigger it with the button. So that kind of stinks. It took me a while to figure that out. So it's not as clean and neat as I thought it would be, but anyway, we'll go ahead and go through how I wired it up, you know, as an alternative. So these are the 4 plugs here. You have positive and negative for your power input, and that is coming from my power supply here. And then you have the trigger side, which is trigger positive, negative. And so what I did was the power's coming here positive, negative, and then the trigger is jumpering from the positive to the trigger to this third line here, this third plug. And then you have this trigger side needs another ground, and so I just jumpered it with the short cable to the ground side. So those are the 4 prongs. The 4 plugs here is positive, negative, power input. Your trigger is also the pin 1 here, and then to pin 3, and then your jump ring, this plug 2 to 4. Then on this side you have 3 plugs, and the middle is common. The upper part here is normally open and the bottom is normally closed. And so right now I have it plugged into, it's just one side of the cord is plugged into the common in the middle, and then I have it in normally open, so on the top here. So what that's saying is that it's normally not running, and then when you run the program and you hit the button, it's going to turn it on. So we'll go ahead and turn it on. So you see the circuit board's turning on, and it's kind of ready to go, but I'll show you the program. I've just run the program P1.1, and there's 4 kind of input buttons here on the bottom, and one of this is set, so I just click and hold it, and that's the program, and you hit it again and it's flashing like ready to program. So these are up and down over here, so I'm just going to click up. 13, 14 seconds, these are all seconds, so I'm going to keep it at 10, and then I'm going to go ahead and set it by just clicking and holding that, and then when it gets back to 0, all right, it's ready to go. So what we're going to do now is it's ready to run, power's running to everything, and when I hit this button, so mimicking when it's in the top of the table and they just come by and hit this, it should turn on everything. So there you go. So it's starting to run the timer down. The little light comes on telling you it's running the program, and that blower is running, so it should, there you go, and then it cut off after 10 seconds. So now it's ready to run again. So you can hit it, and then the kids can mess with it and they can keep hitting the button and nothing will change. It won't turn it off and on. It just runs through that timer, and then when the timer runs out, then it cuts it off. So all right, so here it is done, and sorry about the giant skip ahead in the build. It's kind of taken me a little bit of time to get this kind of put together, and I was just kind of ready to get it done, honestly, and not kind of film every last little part. But what I'm going to do is go into detail and show you guys how I put this together. And so maybe you didn't see me like cut all the pieces and whatnot, but you'll see how it kind of went together. So the last shots I had, I think I was putting this PVC together, and so now it is all glued and in there. And after that, I ended up putting some veneer on this to get it to stain instead of paint it. That was the customer's request. So we're gonna go ahead and get started, and I'll show you kind of from the beginning to end of how this kind of goes together. So we're gonna start over here where the blower motors are. All right, so I have a cabinet door here. I ended up putting a lock on it, and so no one can get in. But so here are the 2 blower motors, and kind of the brains of the operation here with the circuits. So the 2 blower motors, I'll have a link to them in the description. Put them in here and cut the hole. You can kind of see way back in there of going into the other side of the cabinet where the PVC was. So connected that PVC with that shower drain connection, just bolted it to the blower motor with the gasket. Worked out great. So the main part here is the power. I got a power strip here, and I have a hole cut in the bottom to where the power cord will go, and then come out the bottom here of the cabinet so they can plug it in the wall. So the power strip here is powering several things. So we got the two, let's see if I can get it. These two in the back are the actual blower motors. And then I have, this is just like a phone charger, USB a phone charger, 5-volt. And so what that is doing is it is powering the lights that are kind of in the ceiling of the PVC area, so you can actually see the PVC. That was kind of a later addition because after you put the top in and close it all in, it's pretty dark in there. So anyway, then this last power cord here is for this power supply, which actually powered an old scanner, and then I split that to power these two timer circuits. So I'm going to have a separate video of how I wired this up, but in essence, this powers this timer program on this side, and you have a relay, and so the timer runs for 2 minutes. You hit the push button, which are either one of these, and it turns on for 2 minutes. So then it cuts off on its own. So that way the kids don't have to turn it off. It just kind of runs, and then when it turns off, if they want to keep playing, they'll just hit it again. So the power for the blower motors comes into this side of the circuit board, and it's the hot wire, the black wire here, that have it plugged in. So it's plugged into the normally closed, I can't remember which side it was actually. I have it in that other video. It basically ends up being these top two connections that it's connected to. So plug from the power strip, goes into the circuit board, then goes to the blower motors. So I have all these wires. Let's see if I can get it up so you can see up here, are just secured up top here. I'm just going to clean it up a little bit more, and then I have some holes drilled into this wall where the white and the red are connected to the push buttons. Those are momentary push buttons. And then the other cord is the USB that's running these LED lights. So this is basically the cabinet with the blower motors. I have a big grate here with some screen material underneath, and that's because these motors are going to suck in air. It's got to come from somewhere. When you close this cabinet door, it's got to have a way to suck in the air. So it's coming in from underneath the cabinet because it's raised off the ground about a 1/2 inch all the way around. And so it's sucking air up out of this grate and, really out of this hole too. And I put a screen there to keep it from, hopefully keep some of the dust to a minimum that's going to be sucked up into the motors. So anyway, so that's kind of the blower motor side. And again, if you have any questions about any of this, just put it in the comments, and I can maybe send some photos specifically of something you're questioning or whatever, and maybe I can help you out. But anyway, so that is the blower motor side of it. Again, the top here are these PVC. I have 2 PVC outputs for just one motor, and then the same over there. And so your push button is like a momentary push button. It's not one that like clicks on and then clicks off. It just breaks the circuit with just a button. So again, these are 2-inch PVC. Starts out with 3-inch coming out of the blower motor, and then it splits. But in some of that video previously, you saw that I had it increased up to a 4-inch output, and I was going to have this big, like these black spherical swivel pieces. And what ended up happening is that going from 2-inch to 4-inch, it was just too much of a increase in surface area, and so the air just wasn't enough volume to keep the ball in the air. So I had to kind of rethink it. And so my plan now is to have the kids be able to put like these little PVC connectors on it, and they can do it themselves, turn and kind of direct the air. I'm going to get some more of these so they can kind of play with it. But anyway, so that's the tabletop. And so let's go looking at the PVC cabinet. All right, so it's kind of a maze looking. when you look at it this way. It's kind of supposed to. It's just to make it look like there's a lot going on, when really there's not a lot. It's a 3-inch PVC coming out from the blower motors there in the bottom, and then it's just split into 2-inch PVC, you know, and just kind of making my own path on how to get this connected and routed. And then I have this is actually like sneeze guard, like plexiglass type stuff that I put in. And so I didn't realize that I need to put lights in this cabinet, just so when the kids look through these windows, they could see the PVC. The problem is when I put the top on, that it kind of closed it all in, and made it really dark. So I had to add some lights. So if you can see up in here, so from way over there, I don't know if you can kind of tell, there's the holes coming out of the wall there, and the red and the white are for the switches, and you can kind of see them going up to these switches. Not much to it. And then I have the USB is going into this. It kind of came with the light system. It's like a little LED $20 strip of lights that came from Lowe's. And so it has this little adapter that I screwed together and then screwed up into the ceiling. And then the LED lights are kind of just strewn about, and they stick with like a peel and stick kind of backing. All right, so I got the power strip plugged in. We're going to turn the power strip on, and you'll see the circuit turns on, and the blower motor's power buttons are in the on position always. And so we're going to come over here and hit the button. So you can hear it turn on. Kind of levitates the ball, and the lights are on underneath, so that way you can see the PVC. The kids can look at it, kind of see how the air is flowing. So again, I need to get some more beach balls, because that's all I had, just the one. But I think it's like a 6-inch beach ball. I think it levitates it pretty good. I could, let's see, I could cover the hole, and it goes a lot higher, obviously. Drop it down. So yeah, I think it works pretty good. It's a little loud, but I think it's just the air coming out of the PVC itself. It's not like the blower motors. So, I mean, it's not much you can do there. It's the air itself. So we'll let that run until it turns off. But again, I'm going to get some more of these beach balls, and some of that in the back there, that PVC is like a 15-degree little connector piece, and that way they can kind of direct it and have fun with blowing the air in different directions. All right, there you go. So it turns off, and you know, just turns off on its own. So that way when the kids hit the button and run off, you know, after they're done playing, that it just turns off on its own. Anyway, so I appreciate you sticking around for this video, and I'll see you on the next one.